Hi, I'm Wilf. Now I wonder, how many different ways can we construct the periodic table? You're gonna see all of them in this video, so get ready, cause there is a lot. So, as you can see, I've got a periodic table here. I said a periodic table here. So this is my periodic table. So, in the periodic table there are groups and pyramids. No, not pyramids. Periods. And in a period, like this is period 4 for instance, all the energy levels are the same, but in groups, group 2 for instance, all the, like there's similar electron patterns, like that would have hydrogen, it's one on the outside. There's one electron, that is 3 electrons, one on the outer shell. So each time it has one more shell. Yeah, each time it has one more shell, and each one on their very most outer shell, they have one electron. And that's why these guys can bond with these guys. Because they're, like, they have 7 on their outer shell, but they want 8 on their outer shell. All the groups have similar properties, even these ones who don't really bond with anything at all. So, these all have the same energy level. They get smaller going that way, but then each one has one tiny more electron as you go up on this scale. That one is much smaller, even though it's got a higher atomic number in atomic mass. That one is bigger. And by the way, just for fun, did you know it was either francium or cesium? They're the biggest element. I saw this thing on YouTube saying, showing the periodic table, but on how big the elements are sticking it out. I think francium was the biggest. So all the lanthanides and actinides are meant to squeeze in here, separating it all the way out over there. That stays there. You separate it there and you chop that bit. You push it over there, then you squeeze that in. It looks quite peculiar. It kind of looks like a sort of banana, but yeah, it's not a very good banana though. The reason they're down at the bottom is just to fit it on a piece of paper. The problem about this periodic table is that, it goes hydrogen, walk, helium all the way over here, and then to get to lithium you have to go all the way back here. It's not so bad when you go to beryllium and then to boron, but that isn't right, so that's why I'm going to take this off. There we go, much better. So hydrogen would go to helium here. So then it all joins up. Hydrogen, you can go hydrogen to there and to there now, I think. Yeah, around there somewhere. But then instead of having to go, look how far this actually is. Hydrogen all the way around. It's actually quite far. And yep, neon here, all the way around the sodium. Wow, that is super far. Now you can just go hop, Bobby. It's fairly easy. So the problem with that cylinder is that it's hard to make a cylinder like that with just the perfect touch. So here I've got another example. This is the spiral periodic table designed by Harrison. When I think about this spiral here, I can sort of see the periods and rows in this, but it's a bit hard. Hydrogen, helium, lithium, beryllium, boron, carbon, oxygen. Oh yeah, it does add up. The advantage is that it's much easier to make and see and store cylinder, and I think it looks quite pretty. It shows that neon can be next to sodium. That is the alternative circular periodic table. I think this one is confusing, but I still think it's wonderful, whoever created it. It looks quite peculiar. This is the spiral periodic table designed by Jan Scholten. This one is different because it's still circular. I have a like about it because it kind of looks like a giant horrifying spider getting sucked into a portal. I'm a bit confused by it. I still like it because I feel happy for the person who made it. But it is quite complicated. It shows the continuous progression of atomic numbers in a way, and also not in a way. So it's quite confusing. This is Theodore Benfey's spiral periodic table. How can you call this a spiral? It isn't a spiral. It kind of looks like a bird claw. The lanthanides and the actinides, yeah, are on the same prong because they're on the same bit on the periodic table, presumably. But then there's an extra prong with nothing in it. That's good, isn't it? This shows the continuous progression of elements because it just wanders into nothingness. But it also contains the lanthanides and the actinides, which are all radioactive. Fun fact. This is a 3D periodic table called Mendeleev's flower. I think it's very nice. The reason I like it most, one, because it's beautiful, and two, because of the name Mendeleev's flower. It does link things in sensible ways. This is the Carol Ribbon periodic table by Hyde. Well, this is one of our final ones, and I think it's gone bananas. Literally, just gone bananas. There's actually a banana shape in it, so that's a sensible word to use. Yeah, it's nuts. It's nuts and bananas. So this is the Lift Step periodic table by Charles Janet. This shows the exact order in which electrons fill up electron shells. All the electron blocks are like kept together in the same groups because they're in the same levels. I like it because then you can like categorize them. You can categorize them quick and fast. So oxygen's last electron would go in the 2p shell. It's also useful because then in electron configurations they behave in quite the same way, like mostly. I like it also because it just looks nice coloured like this. So I hope you enjoyed this video, and it's probably one of our longest yet. Now if you liked it, hit that subscribe button and hit the like as well. Well, tap the like if you would be so generous. And thanks for watching. Because 2019 was the year of the periodic table, there was a song about it, and there was a woman singing it, and she was a nice woman. And then maybe someone you might know was in it. And I did Mendelevium, because he made it. Come on, you have to do the person who made it.